Welcome to this video looking at detecting nuclear radiation and the different ways that we can do that. By the end, you should be able to describe one of the ways that nuclear radiation is detected. There are 4 detectors that we're going to talk about. These are using photographic film, a Geiger-Müller tube encounter, scintillations, and cloud chambers. It's important to be able to detect nuclear radiation because some people have to work in environments where there is nuclear radiation. It's invisible, so if you can't detect it, you wouldn't be able to see it, so you wouldn't know what harm may be coming to you. Because remember, nuclear radiation can change living cells, causing cancers, or kill living cells. So the first one we look at is that nuclear radiation fogs or turns black photographic film. This is the same as what happens with X-rays, which are related to gamma radiation because X-rays are also electromagnetic radiation, just not quite as high. So here's the film from an X-ray, and you can see that the dark parts are where the bone isn't. So the X-rays have gone through the flesh to turn the film black or foggy. The white parts are where the energy of the X-rays has been absorbed by the bones, and so hasn't changed the color of the film. Nuclear radiation does the same as X-rays. It will turn the film dark. And that's one way that it was actually discovered originally. This is used in a film badge, which is worn by radiation workers. They wear it on the outside of their bodies, and the darker the film, the more radiation that the person has been exposed to. It doesn't tell you how much, just that it has been exposed. You can work out what type of radiation, because they have different metals and different windows, as it's called. So there's different spaces that the ionizing radiation can go through. So for example, in the top, there's no metal there at all. So all types of radiation could be detected by the film here. Here's a few millimeters of aluminium in this part. So this would stop alpha radiation, may let through some beta radiation because it's not thick enough to fully absorb beta. So if something's going through here, then it would have to be beta or gamma. And here with a piece of lead, it's not thick enough to stop all the gamma, but it's thick enough to stop the beta. So if the bottom part of the window is exposed, then that needs to be gamma radiation. If this bit is exposed, then that part there can't be alpha, but it could be beta or gamma. And the top bit could be alpha, but it could also be beta or could be gamma if there's an exposure there. So you can work out the different types that have been detected. So different radiation passes through the different materials. Some are absorbed. The next type is the Geiger-Müller tube encounter. You'll have seen on the types of radiation video this in action. The tube is filled with an argon gas and it's connected to the counter at the bottom here.
The tube has got a protective cover on the front, which if I carefully remove, you can see a very thin window which allows the radiation to pass in. This one here has had the end of the tube removed, revealing a central wire which is positively charged and a cylinder which is the negative connection. Every time the radiation comes in, it will trigger an event which can then be counted by a machine.
Schools may have different types of meters, but essentially they all provide the same function, to provide the voltage to the Geiger-Müller tube and count the events.
The tube has got a protective
Okay, so we can see there's a voltage between the two parts. The ionizing source ionizes the air within the tube, and there's a little event, a little spark, and the counter counts those. It's thin at the front, so the radiation can get through. It's not absorbed. Those pulses are counted and displayed on the counter, either as a needle or a digital display. The display shows the total counts, and if we use it with a timer, we can calculate the activity of the source or the number of counts per second. The final type of radiation is something called a scintillation. Ionizing radiation can cause tiny, small flashes of light called scintillations. And we can detect these and count them and measure the radioactivity of the source. A cloud chamber is another way of looking at the ionization. This is a bit like looking at trails in the sky from aeroplanes, which are vapor trails, but you can see tracks where the radioactivity occurs. You can see thick ones with the alpha source, much thinner ones with the beta because it's less ionizing, and when you have the gamma source on, you can't see anything at all. Okay, so you should be able to describe one way of detecting radiation: photographic film, Geiger-Müller tube, cloud chamber, scintillation counters. Ideally, you'd want to know the first two, as they're the main ones that we'll be talking about during this course.